Hey guys, Buildzoid here, and today we're going to be taking a look at the Gigabyte X570S Aorus Master Motherboard. So this is a roughly $390 dollar motherboard at the time of making this video. I checked the prices on Newegg. I have the board as a review sample from Gigabyte, so thank you to Gigabyte for sending the board over. With that out of the way, let's get right into it, starting off with the rear I/O, where you have a Q Flash Plus button, allowing you to update the BIOS of the motherboard without even having a compatible CPU. Next to that, you get a clear CMOS, so you can, clear the BIOS settings if you screw up, without having to open up your case's side panel or having to rewire your reset button to the clear CMOS jumper. Anyway, below that, we've got Wi-Fi 6 from Intel, a ton of USB ports, which I'm a big fan of, Type A, of course, because that's the useful connector. Still the only, I think still the only device that I have that uses a Type-C is my phone. Then again, I haven't, I'm not very, it's kind of weird. I'm all over, top-end GPUs and graphics cards and memory kits, but everything else is just I'm just going to use something from 5 years ago. What you mean it's old? I don't care. Anyway, 2.5 gig Intel LAN for the networking. And then below that, we've got some audio ports, which I don't cover motherboard audio sections, so that's it. Yeah. Anyway, on the board itself, you get 4 M.2 slots, 3 of which, so you get 2 more down here, and then 1 more at the bottom. These 3 of them go through the chipset, 1 of them goes from the CPU. This is the AMD CPUs just have dedicated lanes for that first M.2 slot. The ones attached to the chipset will either disable some of the SATA ports, or maybe the PCIe slot, or maybe both. The thing is, I don't really care that much about M.2 devices, so technically the board does have 4 M.2 slots. I don't know how much stuff gets turned off if you populate all of them, because I don't care, and if you do care, you can go read the manual. That's why manuals exist. Man, I'm in a great mood today. Thunderbolt connector, if you want to add a Thunderbolt card. And then for the PCIe slots, which technically what you can do with, for PCIe slots, we've got X8 support. So this first one runs X16 or X8. This bottom one can go X8, and this this middle one can do X8, and then the bottom one can do X4. The X4 is off of the chipset, and again, it might get disabled if you have a bunch of M.2 drives installed. Now, the X8 slot, this is real, I'm a big fan of just having more PCIe slots, because let's say you do like M.2 devices, then you can have 6 M.2s attached to this motherboard and still have enough lanes for your GPU. And alternatively, you can also have a capture card in there, or a networking card, or anything, basically. Just PCIe slots can be converted into basically any other type of connector you could ever want. Yeah, that's why I'm a big fan of having just more PCIe slots attached, or just more PCIe slots in general. It's nice also when they're attached directly to the CPU. And with PCIe 4.0, running your GPU at X8 4.0 is really not going to be a bottleneck in any current workloads. So yeah, having the flexibility to just have more PCIe devices, in my opinion, is a really nice feature to have, and not a feature that's particularly common, because PCIe 4.0 switches are actually really freaking expensive. So on a lot of say $200-ish X570 motherboards, you don't get an X8 slot, because the PCIe switches to do that cost way too much for the motherboard vendors to be willing to implement that at that price point. And fair enough, those PCIe switches are really expensive. Anyway, so that kind of covers the normie connector side of things. You've got a clear CMOS jumper over here. You could potentially wire that up to your reset button if you don't feel like reaching around the back of the case for the clear CMOS button in the rear I/O. We've got some totally redundant troubleshooting LEDs over here, and they're totally redundant because we do have a postcode, which is extremely helpful if you're doing a lot of overclocking. There's a power button over here. There's a rebindable reset switch, which unfortunately isn't really that useful on X570. On Z590, Gigabyte has the same thing, where you have a rebindable reset switch, and you can rebind it to, safe boot, go to BIOS, and it can also act as a LED on-off switch. Not entirely sure why you'd want an LED on-off switch. Go to BIOS, I guess, if you're if you can't be bothered to just mash the delete key like a normal person. And the safe boot doesn't work because this is an AMD motherboard. And the way AMD BIOS works is AMD sends a blob of code known as the AGESA to the motherboard vendors. And inside that AGESA is a built-in safe boot function that is extremely unreliable and barely ever works. But also because of that built-in safe boot function that barely ever works, motherboard vendors can't implement their own like third-party safe boot function in the form of a button. So on Intel, like high-end Intel Z590 boards from Gigabyte, you have a perfectly good safe boot function that is extremely convenient and awesome and just makes memory overclocking an absolute breeze. And on AMD motherboards, you're stuck clearing the CMOS because AMD thought they could implement a better safe boot function than Gigabyte could. They can't. And this is one thing that just frustrates me to no end with AMD motherboards is just like, also when AMD puts out an AGSA update and the memory overclocking gets worse. That's also really, really fun to deal with. It's just like, this memory overclock used to work great, and then you update the BIOS and it doesn't work anymore because AMD did something to the memory training procedures. Anyway, so yeah, unfortunately that you can basically just treat this as a reset switch. Gigabyte did add a whole bunch of extra functionalities, but the most useful of them just unfortunately doesn't work thanks to AMD. So good job AMD, very cool, much appreciated. Just yeah. Anyway, up here we have some voltage read points hiding behind the DIMM slots. Not really that useful. Gigabyte motherboards have really good support with like hardware info monitoring, so yeah, I don't like the site. Like you can use them, but personally, it's just like just use hardware info unless you don't want to be running monitoring software while running benchmarks. Which monitoring software lowers benchmark scores. Just you should know that. So yeah, because it's polling the system constantly to read the frickin' sensors. Guess what polling the system for sensor readouts does to other things trying to run at the same time. Yeah, they can't run at the same time. Especially big multi-core benchmarks don't really appreciate having monitoring software running in the background. So in that kind of scenario, the voltage read points can be useful, but like you could just do like a run where you do monitor sensors and then don't do another run where you don't monitor. But anyway, that exists. One of the only downgrades on this motherboard compared to the X570 Master is that Gigabyte ditched the dual BIOS. And on one hand, if you don't know how to use a motherboard manual, it's this booklet that your motherboard comes with, and it's got words in it. You should read them sometimes. Yeah, if you don't know how to use a motherboard manual, and you have a Gigabyte motherboard with dual BIOS with the with the automatic dual BIOS disable switch, I can imagine the dual BIOS function is very frustrating because you haven't figured out how to use the automatic dual BIOS disable switch. And the number of people I see doing that, even people who watch my content where I mention multiple times, every Gigabyte motherboard review where they have a automatic dual BIOS disable switch, I mention that the first thing you should do is disable the automatic dual BIOS because it's frustrating. And the reason Gigabyte includes that switch is because even the engineers at Gigabyte acknowledge that it's annoying. But for whatever reason, so Gigabyte has now ditched the dual BIOS completely, which I guess simplifies the process because you don't have to read the manual anymore to figure out how to disable the automatic dual BIOS. Because there is no dual BIOS, which is which is an unfortunate downside. And at this point, you might be wondering, why doesn't Gigabyte just implement a dumb dual BIOS system like every other normal motherboard vendor? And my response to that is, I have no idea. I've brought this up to Gigabyte multiple times that hey, your automatic dual BIOS is terrible. Like you literally put a switch to disable it onto your high-end motherboards. Why don't you just not have it in the first place, right? And they just don't for some reason. I have literally no idea why they don't. So yeah, you're basically always stuck with the automatic dual BIOS system, and you can't have with Gigabyte. Basically, you either have automatic dual BIOS without switches, which is horrible, and that's what you get on say the B550 Aorus Master, which makes it which basically just that board is very capable, but the fact that it has automatic dual BIOS without the switches is just infuriating. Or you can have a motherboard with automatic dual BIOS and the switches to turn it off, which is fine. That is totally, that's great, assuming that you actually figured out how to disable the automatic dual BIOS. And then, which like, so for, I like that. Like, I don't mind it at that point because you have the switches and it's just like read the manual, flick the switch, and board starts behaving like a normal dual BIOS board. And then the final option is you just don't have dual BIOS, which is what we have here. And yeah, so that's a bit unfortunate as far as I'm concerned, because I really like having dual BIOS for like testing different BIOS versions, especially with how AMD likes to break the AGSA every so often. You know, having the ability to just put the new update onto the other BIOS chip and then find out that it's terrible and go back to your main BIOS again is really cool. You can't do that on this board because Gigabyte, I guess, has given up on trying to explain to people that they should disable the automatic dual BIOS. I still don't get why they do that, though. Like, I don't get it. I just absolutely do not get why Gigabyte even came up with the idea of automatic dual BIOS. Well, no, to be fair, there was a few generations of motherboards where there was a relatively frequent occurrence of the BIOS just, like, corrupting itself. And so if you didn't have a backup BIOS chip, that made life really awkward. But, like, other than that, I don't know why they didn't just have a regular dual BIOS system. Especially on like modern high-end motherboards, like single switch instead of two switch dual BIOS. And some people must be really confused about what I've explained right now, but anyway, if you read the motherboard manual for a Gigabyte board, it should make sense. So I think that covers all of the sort of overclocking features that I wanted to talk about here. So let's talk about the power delivery, and then eventually we'll get to the memory. So for power delivery, we've got two 8-pin power connectors. Unless you're on LN2, unless you're doing LN2 overclocking, you don't need to plug both of them in. Gigabyte uses the solid, Gigabyte uses the high current variant of this power connector, which has solid copper pins instead of like folded metal pins. And you might be like, wait, those are copper, why are they silver? Because you can get copper with all kinds of fun platings like tin and gold, and I think that, yeah, this is just tin plating. So anyway, yeah, so these are the high current connectors, and basically none of the CPUs that you can put into this socket pull enough power on ambient cooling to max out a single 8-pin power connector. You don't have to plug both of them in. This one's there for like extreme overclocking only. And honestly, I wouldn't be too surprised if you could get away with running just the single 8-pin even on LN2. Yeah, like an 8-pin can handle a lot of power, especially the motherboard one. Because for comparison, like GPU 8-pin power connectors only have three 12-volt power, like three 12-volt connections. Motherboard 8-pins have 4 of them. So these are actually about 33% better than GPU 8-pin power connectors, which, yeah, I don't know why GPU 8-pin power connectors are designed like that either. Seems like a real waste of pins, but anyway. Actually, I do know why. It's for hot plug functionality, but like, when have you ever seen it? Like, when has anybody ever used, I guess, servers? Anyway, let's talk about the actual VRM. And this is a VRM that Gigabyte has been copy-pasting around for a bit now. So this is a 14-phase V-core. It is actually 14 phases. They've used this VRM on the Gigabyte X570 Aorus Extreme. They've used it also on the B550 Aorus Master. Motherboards at like opposite ends of the cost spectrum, and now they've used it on a motherboard that's like right in between them. The Extreme is like $700, the Master's like $250-ish, and this is $390, so yeah, right in the middle. Finally have a middle ground between those two boards. And then you get a 2-phase SoC VRM, so we get +2 for the SoC. And this is all controlled by this chip over here, which is of course the Infineon XDPE 132G5C, which is a 16-phase controller from Infineon. It's basically the latest and greatest controller that they make. Fully digital, does all the things that you would sort of want a modern voltage controller to do. Yeah, so that's what's controlling the VRM. There's no doublers, like nothing weird going on, like 16-phase controller. So yeah, you don't really have to worry about anything like that. For the actual power stages, we're looking at a bunch of TDA 21472s. These are 70 amp smart power stages, also from Infineon, and they're ridiculously like efficient. So this VRM will have absolutely no issues powering anything you can put into this socket. You know, with 1.2 volts output voltage and a 400 kilohertz switching frequency, this VRM, while outputting 100 amps of current should only produce about 9 watts of heat, which is actually below the peak of the efficiency curve. Like in these lower current loads, like 100 amps, you would not actually want to be running all 14 phases. I think it would work out best to be running like 10 of them, maybe less. 150 amps output, the VRM should produce about 13 watts of heat, which is extremely good efficiency, and now we're approaching the peak of the efficiency curve. And 200 amps output, this is right around the actual peak of the efficiency curve for these power stages. The VRM should produce about 16 watts of heat. Now, your various Ryzen 5000 and 3000 series CPUs basically run in this range of currents if you're on, ambient cooling. And so, yeah, this VRM is incredibly overkill for anything that you can put into the socket. Now, going above that, so let's say like extreme overclocking territory, we've got like 300 amps output current, which will produce about 24 watts of heat on the VRM. 400 amps output current, it should produce about 35 watts of heat. And 500 amps of output current, the VRM should produce about 47 watts of heat. Like, this is a insanely powerful VRM. It's not new, and it's not the most powerful VRM that you can get on the X570 chipset, but there's really no point going above this. Like, you do not get more efficiency by building a bigger VRM than this. So, yeah, which is why Gigabyte has sort of like, they've used it on the Aorus Extreme, they've used it on the B550 Aorus Master. Real shame that they didn't put proper dual BIOS on that motherboard. And now they're using it on the X570S Aorus Master. So, yeah, in terms of voltage regulation, this is also a really, really good VRM because of the combination of very low, well, for one thing, it's 14 phases, but also we have some very low inductance inductors. These are just 150 nanohenries, which gives you higher, like faster current slew rates and less overshoot on load release because there's just less energy stored in the inductors. For the capacitors, we're looking at 10,000 hour rated 105 degrees Celsius Nichicon FP series capacitors. Same thing on the input filtering. And yeah, like honestly, this is, like for Gigabyte, this is the best VRM they have. And they've just sort of been slapping it on high-end boards for a while now. So yeah, it's really good. There's not really anything to complain about with it. So yeah, like great VRM, and we're just seeing it more like it's just now it's available on even more motherboards. For the SoC VRM, we've got 2 more of the 70 amp smart power stages. Massive overkill for the SoC rail, because the SoC really doesn't have to push much more than 20 amps ever. For filtering on the SoC, we've just got APAC polymer capacitor, molded polymer capacitors. We also have one in the V-core over here, but this is more a case of like they ran out of space for through-hole capacitors than it is like, hey, we want to really maximize the transient response performance of the VRM, which I'm kind of sad about that we don't really have a X570. Well, no, we do now, but not from Gigabyte. Like, but yeah, I'm kind of sad that there's no, like, we don't have a lot of X570 motherboards that go for an all molded polymer capacitor output filtering setup. It's always just through-hole capacitors, which unfortunately have a lot more ESL than these molded capacitors. But Gigabyte has been basically sticking to the molded polymers for the SoC rail. I'm not sure that actually has any advantages, but it certainly doesn't hurt because, yeah, these are just like in terms of electrical performance, these are better capacitors than your through-hole capacitors when it comes to suppressing ripple and transient overshoot and undershoot due to the, well, transients from the CPU. In the socket, we've got this very elaborate bypass capacitor configuration. We've got all of these little multi-layer ceramics. And this isn't really a custom Gigabyte thing. This seems to be a reference design from AMD because there's quite a lot of motherboards using it. Like ASRock has this configuration. Though I think Gigabyte is unique with the mix of like 0805s and 0603s that they have in the actual middle of the socket. I think a lot of other vendors opt to either go only 0603s or only 0805s. Gigabyte does this mix. I don't really think there's much like in terms of performance, I don't really think this makes a difference. Actually, when measuring this really actually doesn't seem to make a difference much at all. Like the thing is, Ryzen's not really that bad in terms of transient loading compared to Intel CPUs. It's just not that noisy. And so Yeah, like this is this is not going to be a bad voltage. Like in terms of voltage regulation, this VRM is very, very good. It's just that it's not very. It's not nothing like like this looks a lot more impressive than it actually is. Like this is pretty standard for AMD motherboards, at least on the high end. So yeah. Anyway, so that's the VRM of the X570S Aorus Master. I mean, literally Gigabyte took the VRM they slapped on the B550 Master and they just slapped it over here. Because the extreme version of this VRM does have more bulk capacitors in it. But those don't really do anything. Because again, Ryzen's just not that hard on the transient loading as Intel CPUs are. Just due to how the chips are designed. So, yeah. Anyway, that's the VRM section of this. And honestly, like, yes, there are VRMs more powerful than this, but there's just no reason to go beyond this as far as I'm concerned, because this already is extremely overkill. So, yeah. Anyway, for the memory, we've got a shielded 6-layer daisy chain. Actually, this is just a 6-layer motherboard, which also applies to the VRM to some extent, because the more layers you have, the more copper you can dedicate to power delivery to the socket instead of signals, like you see these signal traces right in this area, right? Anyway, yeah, so shielded 6-layer daisy chain, and the reason we can tell it's shielded is because we can't see any of the memory traces, right? So there's shielding over all of the memory traces. In fact, this layer is actually empty. I think the shield's one layer down, and then under that we finally have the traces. On the back of the board, you can actually see the ground fills properly, right? This right here is a ground fill. Then this over here, this is actually VDIM. We have more VDIM over here, and actually it looks like they have separate shields for... Oh, I guess that makes sense, yeah. Because you can actually see that this ends over here, the ground fill ends over here-ish, kind of? Yeah, it ends over here. So there's going to be like another internal set of shielding further down inside the board. And this 6-layer like shielded daisy chain from Gigabyte is just amazing. It is so freaking good. Basically, so obviously it's a daisy chain, so it favors these two DIMM slots, but you can run like 4x8 and, well, let's go through the different configurations. So you can, I should really be doing this more by ranks. The thing is, it also depends on what memory chips you're running and what CPU you're running. But as far as the daisy chain topologies that I've tested go, this is the best daisy chain. It is perfectly capable of pushing, 4900 plus on... Actually, not on X570. On B550, it can do that. Not on X570, because X570 doesn't really play well with BCLK overclocking, but over 4800 is certainly doable on single rank B die, which is very hard, actually. So that's Samsung 8 gigabit B die. And yeah, it'll do 4800 on that. If you run like Micron 16 gigabit B die, it'll do over 5000. Like, this is literally one of the best daisy chains on the AM4 platform, and Gigabyte just kind of slaps it across most of their motherboards right now. So it's not unique to the X570S Master, but it's really good. So it's really cool that Gigabyte is just, perfectly happy to just copy paste the best memory topology they have around basically all of their motherboards. For comparison, for single rank, Samsung B-die configurations, a lot of motherboards will actually top out in the 4666 range. So yeah, like this is very, very capable. And then for even like the thing is, when people hear daisy chain, it's like, oh, so 4x8 will be like terrible. Well, no, 4x8 you can go up to 4133, 4200 easy. Like you can max out your Infinity Fabric on a 4x8 configuration, no problem using this daisy chain. And then for 2x16, it's the same thing, because Ryzen's memory controller seems to have more of a problem with the number of memory ranks that are connected to it, rather than the total number of memory sticks that are present. So both 4x8 and 2x16 Samsung B-die actually clock very similarly, at least on Gigabyte's daisy chain. I imagine on some other daisy chains it might not be so... Actually, no, definitely on like 4-layer daisy chains you do start seeing a difference between 4x8 and 2x16, but yeah, this memory topology from Gigabyte is just, like, it doesn't care. which is really cool. Or if it does care, it happens at speeds so high that you can't really get there because of the memory controller. Anyway, yeah, and then, like 2x32, at which point you're looking at like micron memory chips again, which are just easier for the memory controller to run. You're just not going to have any issues. Again, you can just max out the Infinity Fabric. So, yeah, I am, like, this is the best daisy chain topology I've tested. Now, I'm not sure that right now it is absolutely the best daisy chain available on X570, because MSI is coming out with a new daisy chain topology, ASRock has a new daisy chain that I haven't gotten around to testing, and, well, we don't have to worry about Asus, because as far as I can tell, Asus has been using the same memory topology since the launch of X570, and it sucks. So, yeah, that's kind of that. Which, incidentally, the original Gigabyte X570 topology is basically the same as the original Asus X570 topology, so, yeah. Though Gigabyte, I think, was the first to replace... Yeah, Gigabyte was the first manufacturer to change memory topologies. Everybody else sort of stuck around with what they launched, though MSI launched with the first shielded topology, and that was actually for a while, that was the best daisy chain you could get. And then Gigabyte came along with their shielded daisy chain, and this thing is so good. By far, like, if you're going for 4-DIMM motherboards, it doesn't, like, from what I've tested, it doesn't really get better. I honestly think that the new topology from ASRock and, like, MSI probably just matches the Gigabyte one in terms of performance. Because there's got to be an upper limit to how far you could push the memory. Though, yeah, unless I get to test those boards, it's hard to say for sure. But either way, like, this topology already is more than enough to just completely max out the Infinity Fabric on any CPU with any memory configuration, except perhaps 4x16 Samsung B-Die. Because 4x16 Samsung B-Die is quad rank, and the memory controller doesn't like having a bunch of ranks attached to it. So, especially not of Samsung B-Die, because that stuff's heavy, which is why, like, I pointed out the 2x32 configuration, because, yeah, 4x16 in my experience is just a terrible idea. So, yeah, that's it for the X570S Aorus Master. It's kind of the do-everything X570S high-end motherboard. And it doesn't have dual BIOS, which is a bit of a shame. But at the same time, like, I feel like dual BIOS is one of those features that most people don't use, and especially Gigabyte's automatic dual BIOS is a feature that actively makes motherboards worse. So I can totally understand why they ditched it, but, yeah. Also, I think this board's a bit too expensive. Like, personally, I really like B550 motherboards because they're cheaper. They overclock exactly the same as high-end X570s. In fact, they do a better job of BCLK overclocking. And the only thing you're losing is a bunch of M.2 slots, which, as I've mentioned multiple times, I don't care about M.2 slots. So, yeah. But hey, if you do like M.2 devices for whatever reason, this does have 4 M.2 slots built in. And that isn't something you can get on a B550 motherboard. Well, not reasonably get on a B550 motherboard, right? Because these are you have all of these M.2 slots without having to give up any GPU PCIe lanes. So this gives you a lot more flexibility in terms of how much stuff you can, like, how many PCIe devices you can plug in compared to a B550 board. And that's really the main advantage of a high-end X570 motherboard like this. Yeah, that's it. So X570S Aorus Master. Like, personally, I wouldn't be buying this, because I'd buy actually, I literally have a B550 Vision D these days, and that's sort of that is currently my go-to motherboard for Ryzen, because it's just, yeah, like, it doesn't have, like, it's just, man, I'm screwing up this outer. Screw it. Like, basically, I've been saying for a while, I like the B550 chipset better than X570, because it's better for overclocking if you like memory overclocking way too much. For daily, it doesn't matter. There's no difference between B550 and X570 for daily settings. The main thing is you pay extra if you buy an X570 board, and in return you get more M.2 slots. That's sort of the main thing you get. So yeah, if you like M.2 slots, and you're doing like a 5900X or 5950X build, I guess this motherboard is a sensible choice, but otherwise, like even with a 5950X, well, no, if it's the M.2 slots, like that's the X570 feature as far as I'm concerned, is the M.2 slots, because this is where the chipset lives, and this part is completely unrelated to it. So yeah, anyway, that's it for the video. So thank you to Gigabyte for sending this board over. It's capable, but at the same time, well, actually no, there is one thing I forgot to mention. This does have a clock gen on it, and I'm incredibly salty about that, because as I've mentioned, the X570 chipset sucks at BCLK overclocking. And on B550, you don't have a proper clock gen. So on this motherboard, you can adjust the BCLK by 0.01 megahertz increments. On B550, you can't, because nobody makes a B550 motherboard with an external clock gen, which is incredibly frustrating, because on a B550 motherboard, you can go up to like 115 BCLK without any issues. Whereas on an X570 motherboard, you try to go over like 102 BCLK and the chipset freaks out and the system stops, like nothing works anymore. So yeah, that is one thing. It's like, so this board has a clock gen, which is a really cool feature if it didn't have an X570 chipset. Like, I don't know why Gigabyte doesn't just take this and get rid of the, like, I want this, but with a B550 chipset. And that's not the B550 Master, because the B550 Master doesn't have a clock gen, and it has the stupid dual BIOS implementation. So, like, Gigabyte is just doing what they usually do, which is they've managed to build like, technically, they have my favorite combination of features for an AM4 motherboard scattered across, like, 3 different boards, which is just, like, good job, guys. Seriously, great job. Can you not put these all on one motherboard instead of 3 different ones, each with their own downsides? But anyway, yeah, still, like, for a daily, like, for an overkill high-end daily system, I'd say, like, I don't want to call this a go-to motherboard, but, like, if you're looking for a high-end X570, I'd say it kind of is. Oh, I guess I could have also mentioned that it has an active OC switcher, so that's Gigabyte's name of, like, Gigabyte's version of the Asus Dynamic OC switcher. I played around with it a bit. I wasn't particularly impressed by it, but hey, if you want to spend time dialing that in, like, knock yourself out. Yeah. That's the X570S Aorus Master. It's like an X570 Aorus Extreme Light at this point. Did I add an S to that? I think I did. Anyway, there. Now let's actually end the video. So, yeah, thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. Both Patreon and Teespring help out immensely with running the channel, so it would be much appreciated if you check them out. Because, well, yeah, like, sometimes I need to buy motherboards, like ASRock boards and Asus boards. So, anyway, yeah, that's it for the video. Thanks for watching, and goodbye.